Alright, so we're going to look at using the joystick with the Raspberry Pi Pico here. And so you have a diagram of wiring this joystick up. Ground goes to ground or negative. That 5-volt pin goes to actually this 3.3 volt. We have the X and the Y going to our two analog pins, GP 27 and 26. And then we have our switch connecting to pin 16. Okay, and so I've got mine wired up here as well. And so if you look, you can see it right here. It's kind of like reversed, but you got right here we got this one connected to GP16. We got these two right here connected to the analog pins, and then we got the two coming down and connecting to the power rails for positive and negative for ground. And then I just got it right here on the other side. So I have room to kind of move it around and like click it and stuff. Okay. So what we're going to do from here is we're going to go ahead and program that. So let's open up Tawny, and we will write our script here to control the ADC. Okay, and so basically what this guy is, it's two analog inputs, and it's a single switch. Okay, so to control that stuff, what we want to do is we'll call, let's save this. Nope, not open. Let's go to save, and we'll call it joystick.py. Okay, and so what we'll do is we're going to say from machine import ADC and pin, and then we'll say import time. All right, and so basically we're going to initialize an ADC for each of the kind of analog inputs, and so we're going to say X position equals ADC, and I believe we had that on, let me double check. We're looking at pin 26 or 27 for X, and Y position going to be 26, and then the button is going to be equal to pin, and this is going to be pin 16. I'm going to say pin dot in and pin dot input pull up. Probably I did that wrong. I have to fix this. Yep, we're going to modify this just to be pull underscore up like that. Okay, and so now we've got that set up, and we're going to sample them. So while true, we're going to say X in. Let's say this is, well, let's call this X input, and this Y input. Okay, and then we'll just say, you know, X position equals X input dot read U16. Again, I gotta double check that I'm using the right yeah, I think we're doing that right. So now we'll copy this one, and we'll copy this one. We'll say Y position, Y input dot read, and then we're gonna say button state equals button dot value, like that. And so now let's go ahead and print this out. And we're going to make an F string. We're going to say print F, and we're going to say X, and then we'll do X position. We'll say Y position, then button, or we'll just do SW for switch. And then we're going to say button state. And let's actually, instead of comma, let's use the pipes to separate them. Okay, so let's, then we gotta end our quote, end our parentheses, and let's do a time dot sleep of 0.1 here. Okay, and so we run this, and we see that output there. And, so you can see I'm moving it up and down. You can see X changing. I'm moving it. Oh, I guess I have them reversed. So if you have your pins switched, you can just switch those two pins here, or you can switch them on the hardware. And then when I press the button, you can see it go to 0. Got the X changing. Got the Y changing. Now do you see how it kind of jumps? It would be nice if we can format it so it takes up the same space no matter how big that value is. And so the way that we do that is we're just going to put a colon here, and it's when it's 65,000, 32,000, whatever is 5 spaces. We're going to put 5 right there. And I believe this will have it always take up 5 spaces. And so now, yeah, look at that. So now the formatting doesn't get wonky on us. And you can mess around with controlling that position, pressing that button, and now we got a joystick. There you go. Next step, we'll use it to control a servo, control some lights, stuff like that.